Hi, this is Mrs. Young, and this video covers the volume of prisms and cylinders. Previously, we had been talking about surface area, and now we switch over to volume. I honestly think volume is a little bit easier than surface area, and I hope you think it's a little easier too. Surface area is covering the surface of a three-dimensional shape, like when you wrap a present. Volume is the space to fill it up. So in our ball ringer right here, go ahead and make sure you have your spiral out, and I'd like you to try to find the surface area. Again, this is a review of our previous unit. Find the surface area of this shape. This shape is a little tricky because it's like they took a cube and drilled a hole through the middle. So you've got the surface area of that cube. You're going to have a circular opening on the one end and then a circular opening on the other end. But then also, as you drill through the middle, you actually have the lateral area of that cylinder. So pause the video and go ahead and see if you can come up with the surface area of this composite figure. Again, it's a cube with a cylinder drilled out of the middle. So it looks like there's an opening going through the center here of that cube. So go ahead and pause it. So again, like I said, this one's a little tricky. The surface area of the cube, so 6 times the side squared, and then I subtract out the circles on the front and the back. So I subtract out those 2 circles, 2 pi r squared. Again, our radius was 0.75. So I have 33.9657. And then for my lateral of the cylinder, again, you've got this surface in here that's the lateral of that cylinder. So that's 2 pi RH. And then when I add those two values together, you should get a total surface area of 45.7. Again, this is a little bit more challenging composite figure. Sometimes it's hard to visualize what you're seeing in that picture. So moving on to our notes on volume. Volume, what is volume? Volume of a three-dimensional figure is the number of non-overlapping unit cubes of a given size that will exactly fit the interior. Okay, so it's like you're filling up the shape, the space that it takes up. Our units are going to be to the third power. Again, area and surface area, your units are squared. Volume, your units are cubed. There's something called Cavalari's principle that says that if two three-dimensional figures have the same height and have the same cross-sectional area at each level, so again, this triangle has the same area as this cross-sectional triangle, then those two three-dimensional shapes will have the same volume. So again, they're showing you a picture of a right triangular prism on the left and then an oblique triangular prism on the right. And they're saying that they both have the same volume. They both take up the same amount of space. I know in the surface area part of this unit, I said that we weren't going to worry about oblique prisms, but with volume, we may have some problems that deal with oblique prisms for volume because it's the same formula. You're going to use the same formula to find the volume of the same type of oblique prism that has the same height and same cross-sectional area. Here's a little visual picture of what they're talking about too. This is a stack of CDs. Again, I don't know if you know what a CD is, but there's a stack of CDs on the left, and they took that same stack of CDs, same number of CDs, and then just kind of tilted it to the side. So that's an oblique prism there on the right, but those two take up the same space because they still represent the same number of CDs, right? So again, this is called Cavalari's principle, just something that's kind of unique and special about these three-dimensional shapes. I do have a couple of volume formulas I'd like you to jot down for me. The volume of a prism is the area of the base times the height. So the area of in this example, the triangular base times the height, that's what the capital B means. And again, even if it's an oblique triangular prism, the area of the base times the height. Again, the height is always going to be perpendicular to your base. The second formula there is the volume of a rectangular prism. Again, the base of a rectangular prism is a rectangle, which is length times width. That is your base times the height. So again, length times width times height. You, I'm sure, have seen that formula before. And then finally, a special one here, a cube. Because your dimensions are all the same, the length, width, and height are all the same value. It's just the side times the side times the side, which is the side cube. So why don't you just pause the video for a minute here and just make sure you have those three formulas jotted down. So here's an example of a problem where we might want to find the volume of this rectangular prism. Again, a rectangular prism is length times width times height, which in this case would just be 13 times 3 times 5. 13 times 3 times 5 is 195. That is a really simple problem on volume. But what if we had maybe a bit more challenging shape than just a rectangular prism? What if, as an example, we had a hexagonal prism? So again, this is a right regular hexagonal prism. Right means that it's standing straight up and down. Regular means that the base is a regular hexagon. And we want to find the volume. Again, we know that a volume of a prism is going to be the area of the base times the height. But the challenge here is that our base is a hexagon. So maybe somewhere in your spiral, go ahead and draw a hexagon. Draw a hexagon. And we know that this hexagon is 9 feet on each side. It's a regular hexagon, which means each side is 9 feet. And I'm going to draw in my center point, and then draw my central angle, and then draw in my apothem. So again, if that whole side is 9, half of that is 4.5. I know if it's a hexagon, this angle right here is going to be 30 degrees. We've created a 30, 60, 90 triangle, which means our apothem is 4.5 root 3. So if we want to find the area of that base, which is a hexagon, the area of our base is 1/2 times the apothem times the perimeter of the hexagon. So we're going to say 1/2 times the apothem, 4.5 root 3, times the perimeter of the base. Well, 9 times 6 is 54. So if we multiply these together, it does say to round here, so I can use my calculator. So I'm going to take 1/2 times 4.5 times the square root of 3 times 54. So again, using your calculator, go ahead and plug that in. I'm going to come back to that in a second. Again, our formula for the volume is the area of the base, which is our base is 1/2 times 4.5 root 3 times 54. Again, that's the area of your base, times the height, which we know is 12 feet. That prism is 12 feet tall. So again, we have it as the area of the base times height. So you can plug that whole thing into your calculator. And I'm hoping or guessing that you come up with 2,525.3. Again, my units are cubed, so this is feet cubed. So go ahead and check and make sure that you can come up with that same answer that I got. Again, the area of the regular hexagon, that's our base, times the height. Okay, so then moving on to another shape. Let me just check that. Yep, that's right. The next one, it says, find the volume of a triangular prism with a height of 9 yards, whose base is a right triangle with legs 7 and 5 yards long. This one doesn't actually have a picture, so I'm going to start by drawing a picture. My base is a right triangle. Well, I'm just going to go ahead and start by drawing a right triangle. Draw a right triangle. And it says that my right triangle has legs that are 7 and 5 yards long. So 7 yards and 5 yards in my right triangle. And this is actually, that's a two-dimensional shape, but I want to make this into a triangular prism. So I'm just going to go ahead and draw lines kind of going to the back to give myself this three-dimensional shape. So there's my triangular prism where it says that the height is 9 yards. Well, my triangular prism is kind of laying down on its side. So here's my height. That's 9 yards. Again, to find the volume of a prism, it's the area of the base times the height. So again, my base is a triangle. A triangle is 1/2 times your base and height of that triangle are perpendicular to each other, right? 5 times 7. And then the height of my triangular prism is 9. This looks very similar to our rectangular prism, right? Where you just have length times width times height. But notice here it's 1/2 of that because it's half as big. It's like you take a box and chop it in half. That gives you your triangular prism. So 1/2 of 5 times 7 times 9. Plug that into your calculator. I want to say I came up with 157.5 yards cubed. And again, my units are to the 3rd power. So 157.5 yards cubed. So that's our volume of that triangular prism. Next, we're going to move on to our cylinders. Cavalari's principle also relates to cylinders. And I'm giving you a couple different types of pictures here to look at. You've got like CDs not in the case, right? So these are the same number of CDs, so they would take up the same space or volume. And here's just some little cardboard circles cut out, right? So they have the same number of cardboard circles. Again, notice that the height is the same, right? The same height, and the same number of cardboard circles will give us the same value. And they're even showing an example here with pennies. Again, they're showing you different types of oblique prisms here, and again, they're still going to have the same volume, whether it's a right cylinder or an oblique cylinder. And our formula for a cylinder, again, think about our prisms. It's the area of the base times the height, but your base is a circle, so the volume is pi r squared h. So go ahead and pause this for a second and just go ahead and jot that formula down with your other formulas for today. Again, our volume is still base times height, but our base is a circle, so that's pi r squared, that's your base, times the height. So go ahead and pause this and jot that formula down. Okay, so it says find the volume of the cylinder, give your answer in terms of pi, and round it to the nearest tenth. Let's just do in terms of pi right now. Let's just keep it easy. I can see in my cylinder that the diameter is 18. That means that my radius is 9. So for my formula, the volume is the area of the circular base, pi times the radius squared, and then times the height of my shape. Again, your height's always going to be perpendicular to your base, even if the shape is oblique. So that has a height of 14 inches. So let's see, 9 squared is 81. 81 times 14, use your calculator. I came up with 1,134 pi. And again, this is going to be inches cubed. So again, double check and make sure that you can come up with that answer. So again, same formula, whether the cylinder is right or oblique. Make sure that your height is perpendicular to your base, and make sure you're dealing with your radius. So that's a pretty easy one. Let's try another one. Find the volume of a cylinder with a base area of 121 pi centimeters squared and a height equal to twice the radius. And again, let's just do our answer in terms of pi. You can always get the nearest tenth if you plug it in your calculator. If our base area is 121 pi, again, we know our base is a circle, so that means that pi r squared is 121 pi. So what would my radius be? Yep, we know that 11 squared is 121, so we know that our radius is 11. Good thing that we learned our perfect squares, right? So then the volume of our cylinder is pi times the radius squared. And then our height, it says here that our height is twice the radius. So twice 11 is 22. And again, 11 squared is 121. 121 times 22. I'm going to get 2,662 pi. And again, this is centimeters cubed. So just double check and make sure that you would come up with that same answer as I just did. So again, we've got our cylinders and our prisms for volume. Consistently here, it's the area of the base times the height. So in my next problem, it says the length, width, and height of the prism are doubled. Describe the effect on the volume. So let's just first find the volume of this shape, of this prism. Again, we know the volume is length times width times height. Multiply those together for me. What is 1.5 times 4 times 3? Well, I know 4 times 3 is 12, and 1.5 times 12 is 18. So I would get a volume of 18 feet cubed for this prism. Now it says, what if we doubled our dimensions? So what if instead of having 1.5, we doubled that and now we have 3? Instead of this being 4, we double that and we have 8. And we double 3 and we get 6. So now our volume is 3 times 8 times 6. Let's see, 6 times 8 is 48. 48 times 3 is 144. So what effect did this have on our volume when we doubled the side lengths? So if we took 144 divided by 18 on our calculator, 144 divided by 18, that's 8. Again, we doubled our values. So think about it, 8 is the same as 2 cubed, right? 2 times 2 times 2 is 8. So remember that in area and surface area, it was going to be our scale factor squared. Here, it's going to be our scale factor cubed, right? 2 cubed is 8, so my volume is going to be 8 times bigger. It's kind of an important property to remember, and hopefully it makes sense that, again, we're in 3-dimension, we're talking about volume, and that's why it's to the 3rd power, because everything, all 3 dimensions, were doubled. And then finally, my last problem here for today is a composite figure. It says find the volume of the composite figure, round to the nearest 10th. Oh, and exact. Oh, and don't you love that I put the answer on the screen for you? Okay, so I'm going to walk through this one with you. I'm going to start with the volume of the prism at the bottom, the box. So the volume of our prism is length times width times height. 4 times 5 is 20. 20 times 8 is 160. So that rectangular prism at the bottom has a volume of 160. For the triangular prism, to find the volume of our triangular prism, again, it's the area of the base times the height. And again, our base is this triangle. Well, be careful because I know this side is 8, I know this side is 8, I know this side is 8, so I know this is an equilateral triangle. So I'm trying to figure out the height of this equilateral triangle. Again, if the whole side is 8, half of that is 4. I know that I have a 30, 60, 90 triangle, so the height is going to be 4 root 3, right? You got a 30, 60, 90 special right triangle. So the area of the triangle, that's our base, our triangle. A triangle is 1/2 times, again, the base of the triangle is 8, and then the height of our triangle is 4 root 3, times the height of the actual triangular prism, right? We know that's 4. So for our triangular prism, half of 8 is 4. 4 times 4 is 16. 16 times 4 is 64. So I get 64 root 3. Again, that's the volume for our triangular prism. If we add those two volumes together, we're going to get our total volume. So it's going to be 160 plus 64 root 3. Again, that's where they came up with that answer. Again, it's to the 3rd power. Our centimeters are cubed. In volume, you're not worried so much about in surface area. Remember we always said like there's no surfaces in the middle, it was hollow, but here we want to find the total space that the shape is taking up. So you find the volume of each shape and then just add them together. So again, that's volume of prisms and cylinders. Our homework for tonight is pages 37 and 38 in our packet. I did alter the assignment here. I made it a little bit shorter. It's 13 through 29. Again, make sure that you're drawing your shapes and showing your work. So again, homework for tomorrow, page 37 and 38, 13 through 29.